One of the functions of the kidney is it regulates systemic blood pressure. So let's think about what's going on here. Well, here we have a kidney, and of course it's essential that the kidney is well perfused with blood. So as you probably know, we have the aorta, and the renal artery is a branch from the aorta. And the kidney needs to make sure it's well perfused with blood. So what happens is, you know there's the afferent arteriole taking blood into the glomerulus. There's the efferent arteriole as well, of course. And here we have the glomerulus, which is the ball of capillaries. Now, in the walls of the afferent arteriole, there are specialised smooth muscle cells. And if the pressure of the blood here is reduced, then that's detected in the walls of the afferent arteriole. And the afferent arteriole, the cells in the wall of the afferent arteriole, those specialised smooth muscle cells, they'll respond by releasing an enzyme called renin. So as blood pressure drops, more renin will be released. And conversely, if the blood pressure is good, if the pressure of the blood in the afferent arteriole is good, less renin will be produced. And the aim is to maintain the flow of blood to the kidney. So how is this renin regulating the blood flow to the kidney? Well, up here we've got another organ, the liver. And the liver produces a protein, and this protein is called angiotensinogen. So angiotensinogen is a protein produced by the liver, and it circulates in the blood and it doesn't do anything unless it's acted on by renin. So the angiotensinogen is inactive unless it's acted on by renin. And what the renin actually does is it clips a sequence of 10 amino acids, just a small peptide, from this angiotensinogen protein. And that is angiotensin type 1. So the more renin there is, the more inactive angiotensinogen is converted into angiotensin type 1. And then this angiotensin type 1 is going to circulate around the body, and particularly when it goes through the lungs, it's acted on by another enzyme, and this other enzyme converts the angiotensin type 1 into angiotensin type 2. All it does is there's a couple of amino acids clipped off this. So this is a smaller peptide of only 8 amino acids. But of course this won't happen without an enzyme. And this enzyme, as we've said, is primarily present in the lungs. And this enzyme is the angiotensin converting enzyme, the ACE enzyme. So the presence of the angiotensin converting enzyme in the lungs converts angiotensin 1 into angiotensin type 2. And the angiotensin type 2 has several effects. Firstly, the angiotensin type 2 is a very potent vasoconstrictor. It's vasoconstriction. It vasoconstricts peripheral arterioles. And if you constrict the peripheral arterioles, you're going to increase peripheral resistance. And if you increase total peripheral resistance, you'll increase blood pressure, because blood pressure equals cardiac output multiplied by peripheral resistance. So the more peripheral vasoconstriction we have, the greater the peripheral resistance, that's going to increase blood pressure. So we're going to get vasoconstriction. And also the angiotensinogen type 2 will stimulate the secretion of aldosterone. From the adrenal gland. And aldosterone will increase the reabsorption of sodium from the renal tubules, meaning you have more sodium in the blood. It increases the amount of sodium in the blood. And sodium, of course, is very osmotic. That's going to attract more water. So that will increase intravascular volume. If we increase intravascular volume, we're going to increase venous return to the heart. If you increase venous return via the Frank-Starling reflex, more blood will be ejected from the heart in a 1 minute period. Cardiac output will therefore be increased as a result of the raised intravascular volume. If you increase cardiac output, you're going to increase blood pressure, because blood pressure equals cardiac output multiplied by peripheral resistance. So both of these effects are going to increase blood pressure. If systemic blood pressure is increased in the healthy person, that's going to increase the perfusion of the kidney. If there's increased perfusion of the kidney, blood pressure in the afferent arteriole will be higher, and that will inhibit the release of renin. If the release of renin is inhibited, there's going to be less renin present in the blood. That means the inactive angiotensinogen will remain in its inactive form, and therefore will not become angiotensin 1, will not become angiotensin type 2. And of course, I'm sure you've all given out drugs called angiotensin converting enzyme inhibitors in pharmacology. These work by inhibiting the angiotensin converting enzyme, therefore preventing the conversion of relatively inactive angiotensin type 1 into highly physiologically active angiotensin type 2, therefore preventing the vasoconstriction, preventing the release of aldosterone, therefore keeping blood pressure down. That's why angiotensin converting enzyme inhibitors are hypotensive agents. They're used in the treatment of hypertension and indeed other things. And indeed, angiotensin type 2 will also affect glomerular filtration rate. And changes in glomerular filtration rate also have the ability to influence the amount of sodium and the amount of fluid retained in the body, or the amount of fluid excreted from the body. So we notice that the kidney produces the renin, acting on the angiotensinogen produced by the liver. Thereby, the kidney is controlling vasoconstriction, aldosterone secretion, and glomerular filtration rate itself. And it's considered that in most Western countries, the prime cause of hypertension, which we have plenty of, there's lots of people that we need to treat with high blood pressure. The prime cause is that the kidney is secreting too much renin. That is the prime cause of most essential hypertension in Western countries. For African populations, it's slightly different, because African populations are often salt-retaining people. They are salt-thrifty, and their hypertension can be caused primarily by the increase in the amount of salt in the blood, the amount of sodium. But for Western populations, too much renin. But of course, we can interfere with this pathway by giving angiotensin converting enzyme inhibitors. So the kidney is one of the prime organs in the regulation of systemic blood pressure.